Hello everybody, in today's tutorial we're going to make the ugliest app ever. So in today's tutorial we're going to make an app which can do record and play for Dynamixel motors using our EVK. So we already know how to put a lot of things together for Android app. I'm assuming that you have gone through the other tutorials on my channel, and assuming that we're going to go ahead this time without going step by step. I have the confidence that you guys should be able to just copy paste things from files that I'm going to share, or you can even load the entire project solution to load the files. So this tutorial is going to be more about explaining how each part functions and how to put, what sort of buttons to put and what sort of things to put there. So I'm not going to focus on how to put, but what to put. So I start with the layout file. So I am currently on the activity main XML file. So let's see what sort of buttons we have right now. So I know this looks really ugly, but let's just focus on the functionality. So we have a discover button that's basically going to show all the robots available on that network. So if you're on SA mode, of course this is going to be one robot, but if there are if you're on a network, and then it's going to show all the robots available to be connected on the network. So you just have to hit the discover. It's going to load all the device names on the spinner item, and once you choose a spinner item, it's going to show its name and its IP over here. So that's pretty much that for the discovery part. Now we hit connect. In the previous video when we hit connect, we also showed the video. In this video I'm not going to show how to do the video part, but more on how to do the record and play part. So in this video, when you hit connect, it's not going to show you a video from the robot. So that's also an advantage. In case your robot does not have a webcam connected to it, you can just use it for record and play at least. So we have a few more buttons here. Enable. So when you click on enable, it becomes disable, and vice versa. So enable means you're going to turn off or turn on the motors that you have on the robot. And record new frame basically means it's going to record whatever positions the robot is currently on. So the idea is you use the enable disable buttons to kind of let's say you disable the robot and then you move it with your hands, and then you record the new frame. Every time you record a new frame, it's going to add it to this list of frames over here. So it's another spinner item, and the spinner item is also going to keep getting added with the new frames. Suppose you want to make a new action completely, you're going to do a new action, and then it's going to load by default a neutral frame in the spinner item. I've not put a lot of checks like whether you're connected before you're pressing record new frame or playing action. I assume that you can do it yourself, and you should. There are a lot of tips that I'm going to give at the end of this video where you can basically put a lot of new features on top of this. Now to explain how an action recording will work is basically, first you need to understand what a frame is going to be. So when we say record new frame, it's going to record the positions that it is currently at. It's also going to put some values. So by default it's going to put a duration of 1 second, and it's going to put a pause of 0 seconds, but you can change these values in each frame, and by that it means that each frame has a duration to go from the previous frame to this particular frame. So for example, I recorded a frame of some 10 degrees of some particular motor, and then I created another frame with 50 degrees, and it needs to go from 10 degrees to 50 degrees. So there's a difference of 40 degrees. It's going to calculate based on what duration you give. So it's going to calculate the RPM of motor required. Suppose you want to pause after going at that position, it's going to pause after reaching that position. I'm going to show you a live video of all of this, so don't worry if you can't understand what these things mean exactly right now. Save frame is basically going to save any values that you change over here. These are edit texts, so also called as plain text on Android, and so the duration and pauses can be changed for each frame. When you save frame, it's not going to save it on the file, it's going to save it just on this particular this action object that we're going to create in the main activity. When we save the whole file, it's then going to save all the things, all the changes that you have made on each frame, and then you're going to save it in the file. You can of course load a new file, and you can always create a new action if you're not satisfied with the one that you already have. You can even override the action by just creating new action with the same name. Another feature that I put is a neutral button, which is going to set your robot into a neutral frame. So now, before going ahead, what I'm going to do is show you a short video of how these things function together. Now that I've explained all the functionalities, I'm going to record a video of the app and the robot together. So today we have a spider robot, so we're going to show a spider robot. We're going to record some actions and play some actions and see how it goes. Okay, let's have a look at how the app works. So we open the app, we click on discover, and we see that the robot is discovered. Now we connected on the robot. And we disable the motors, and you can see that all the legs just went down. Now what I'm going to do is, since I disabled the robot already, I'm going to lift its leg, record new frame, and I just saw that, oh, there's one extra frame here. Now I'm moving the leg and recording new frames. New frames get added. And now I'm going to click on play action, and it plays the action. That's nice. And just press neutral, goes on neutral. And now I'm going to change the timing for frame 2. So now I've saved and I'm playing now, so it's going to stay at that place for 2 seconds. It also went slow initially, if you noticed. So I think that covers most of it. I'm going to save it. I saved it. I closed the app. I'm going to kill the app. I'm going to open the app again. I'm going to discover. I'm going to connect. I'm going to load. When I load, I'm going to see hello, since I saved it as hello. There are all my frames. And I play, and it's going to go slow, and then it's going to pause for 2 seconds, and then it's going to continue all the frames after that. And voila, everything done. Okay, so now that we understand how the app works, I'm going to go ahead, just let's go to the text version of this XML file and just have a look at what all sort of IDs I've given and what sort of on-click listeners I've given. So we have bdiscover, and it's going to have discover as a text, and it's going to have bdiscover click as the on-click function. Similarly, a bconnect button, and then there is text view, which we don't care about naming because anyway it's not going to be accessed by us. I mean, usually we don't change things much, but anyway, so we're going to change the IP and the device name every time we change the spinner. We have the devices spinner, which is going to show all the available devices, and then from the previous video I still have here the GV video. We have benable, which is basically the button that's going to disable the robot's power. We have brecord, which is going to record the new frame. We have bplay, which is going to play the entire action, not just that frame but the entire action. It has on-click listener of bplay click. I've basically named all on-click listeners as that button underscore click. Then we have new action, we have save, we have another spinner for the frames that we have in that particular action, and we have bload. That's going to load a new file that we have already saved before. We have et duration, where we can change the duration, and then we have save frame, which basically every time we change the values of duration or pause after each frame, we can just save that frame. So it's not automatically going to save it, we have to save the frame using the button. Then we have be neutralize, which is actually neutral, so every time we press the be neutralize, it's going to neutralize the robot. We're going to come on the main activity soon, and I'm going to tell you how to set all these things, where neutral, what does neutral mean, and all of that. Then we have action name, so every time you load a file, it's going to show the name on this particular text view. And then we have edit text pause, that's going to show where you can edit the pause of each frame. Now let's go to the main activity. So now over here you can look at from the starting. First of all, before even we go to the main activity, we have to set a few things. So let's assume that our robot only has Dynamixel protocol motors as of now. Alright, so assuming that, let's see what sort of robot we have tried making here. So we saw that the spider that I showed in the video had 12 motors, 3 on each leg, 4 legs in total. So the motors that were used were AX12. Now over here we have a byte which mentions the type of motor, basically AX12, AX18, MX28, MX64, 106, XL320, etc, etc. Then we have the IDs of that robot. You can set your IDs according to your robot, but this robot has IDs from 1 to 12. And then the motor types, so there are 12 motors, so there are 12 motor types, each of them being AX12 in this scenario. Then there is one byte array which is all enabled. This basically means that we'll be using these things later in the code. This basically means that we're going to use this array for enabling all the each motor. Similarly, we have all disable, is going to disable each motor. So you can have like something different. You can just enable, disable left leg, right leg, left front leg, back leg, things like that. So you can make your own arrays, and it's going to be used in that sense. We have a standard baud rate on this robot is 57142. Then the neutral position is what I was going to talk about. You saw the neutral button on the app. So when you press the neutral button, these are the values that go on each motor. Now mind it, these values are in terms of degrees. I prefer degrees. You can change the notation according to your choice after you understand how the code works. So you'll see that each motor goes on 150 degrees. These are AX12 motors, so 150 basically means 512 in terms of their analog values. So 150 degrees, since 300 degrees is the max value, so 150 becomes the exact center of each motor. So the moment I press neutral, each motor is going to go on 150 degrees, which is the center. Now how fast are they going to go there? So the next array is going to tell how fast each motor is going to go to the neutral frame. Every time I press the neutral frame, I have set the RPMs as 10 RPM. Total number of motors is 12. Now this class, we have defined a robot. You can always change the robot that you have. So if you have a humanoid with 26 degrees of freedom, you can put 26 motors and explain each ID and each motor type, etc, etc. Similarly for lower number of motors. Now what do we mean by a frame? Now again, this is an important thing. So every frame has positions of that particular frame. It has the duration, which means how much time should it take to go from the previous frame to this particular frame. And then there is pause, which means that after it has reached the position from the previous frame to this particular frame, how long should it just pause over there until it goes to the next frame. So now we have these three things: positions are obviously something similar to, a double array like we saw here. Now you're going to see some constructor functions for this frame class. So the most basic constructor that I've made is you just put the number of motors and it's going to create a new double and give 150 values to all of them, and set the duration and pause. Or you can give the positions of the new frame, and then it's going to set by default the duration and pause to 1 and 0, so you might have to change that. You can create your own constructor function with duration and pause as an argument. Now finally we are into the main activity. Now the code might look very similar to you from the previous time. I mean, there are not a lot of changes except for the new things. There are few changes in the classes of robot.com and TCP client, so I really recommend that you make changes if you're trying to use the previous code from the previous lecture. I would not recommend that. I would recommend that you copy the things again from this particular tutorial. Now we're looking at what all things do we have here. So we have the buttons, we have the spinner, etc, etc. We have some booleans which are connected, enabled and playing. These booleans allow us to keep a track of toggle buttons basically. On top of that we have a robot.com class called robot, and then we have a robot spider. So this is similar to the class that we just made over here, and we are just creating a spider as an object of that particular class. Now we have the current frame, which is 0 obviously, and then every time we change the spinner item from the drop down menu, it's going to change the current frame. And we have obviously the other things that I've already mentioned from the XML file. Now we come on the onCreate button, onCreate function, and we look. Most of the things are again the same over here. We're going to see that we have b enable, b duration, et duration, et pause, spinner frames. Again with the spinner frames, every time we click the spinner frame, the duration and the pause should set according to that particular duration of that particular frame. So it's going to set the current frame to that position as well. A major thing that I forgot to discuss is a list of all the frames. This is the most important part of this function, of this entire class. We have created an action by creating a list of frames. This basically means that each action is just a combination of multiple frames, a sequence of frames. In my terminology, in the terminology that we usually use here at Sirena Technologies, is by frame, I've already explained what a frame consists of. Action is a list of frames, and then we say something called a sequence, which you might have observed in the Windows tool. A sequence is a combination of actions, a list of actions, a list of music changes and sound changes and light changes, and all of these together make sequences. So it's really important in terms of the terminology that we're straight, because when it comes to sequences, also a lot of synchronization that is required with respect to the action and the lighting and the music and etc. But in this tutorial we're just going to do how to record an action. So that is basically how to record multiple frames and just join it together. So that's simple. So we have already gone through how Discover works in the previous tutorial, and how to connect to the particular thing. So those things are going to stay almost the same, except for that I've removed the video task from the connect button. In this tutorial, what we are going to focus on is basically the recording things, right? So let's start by creating a new action. Every time we create a new action, we're going to have an alert dialog builder. So alert dialog is basically something like a pop-up window. So the pop-up window is going to have an edit text, and you're going to put something and you can press OK. You can even have a negative button like cancel. I've currently commented it, and it's going to have an on-click listener. Every time you press OK with the new text, it's going to create a new action for you. So look what it's going to do here. Okay, it's going to create a new alert dialog and it's going to show it to you. When you click OK, it's going to do these things. So let's go through each line. First of all, it's going to set the current action name as the text that you have put. Then it's going to obviously set the action name on the screen, the text view, to the action name that you've just entered. Then it's going to clear all the action that you already created. So it's very important that you don't click it. Of course, you can make more alert dialogues to make sure that the user did not press it by mistake. You can always do that. Then we're going to do something here. This is kind of important. We're going to add a new frame of 12 motors. By 12 motors, you probably have to change, let's say spider dot number of motors. This will still work. So it's going to create a new frame and add it, basically a neutral frame. We can even change this and do something like spider. Okay, let's not do that. New frame, and I'm going to send it the neutral frame of spider. So your neutral frame might be different, the spider's neutral frame might be different. So we're going to create a new frame using the neutral positions of my spider, and then we're going to update the spinner frames. So now we need to go on the update spinner frames button. So now we are here on update spinner frames. Over here it's going to just set all the new frames that are there in your action according to the action size. It's going to set the entire spinner and going to show you. That simple. Now that we're done with creating a new action, now the next thing that we're going to do is record. So now we are on record. So we assume that record is okay by default, but there could be errors that could pop up. For example, your motors may not reply properly. In that case, it's going to return a 0. The function is going to return a 0. If there is a 0, that's very dangerous. Your robot can go to 0 position really fast. So it's really important that we check is there a 0 in that particular recorded position that we have just recorded. If there is, it's going to re-record it, just like a fail safe. It's going to check once more. It's not going to do it in a loop, because if you try to do it in a loop, it might get stuck there. So you just do it once. If it doesn't work, we try again. If it doesn't work, we just set OK record equals to false. If OK record is false, then we do not add anything. But if it's OK, then we're going to add the entire frame that we just recorded. Again, we're going to update the spinner frames, and we're going to set the selection to the latest frame that we have recorded. This way the changes that you make on the duration and the pause reflect on the particular frame that you're using according to the current frame. Now what I missed is the recorded positions. How do we get that? So that's really important. We already know how to make the robot class. We've been doing this for the last few lectures, so I'm not going to focus on that. In the robot, I have mentioned a new function called read sync AXMX. What this does is you just have to tell the IDs that you want to record, the motor types of these IDs that you want to record, and you're going to set the baud rate of that record. And once you do this, it's going to record the entire thing. I'm going to give you an array of positions as a response, and you can look at all the positions in this particular double array. Now that we are done with record, probably we want to go next to save frame maybe. So I'm going to look where it is, right here. What does save frame do? So suppose you made changes in the duration or pause of that particular frame that is currently selected on the spinner of your spinner frame. It's going to do this. So it's going to do action.get current frame. So it's going to get that particular frame that you are currently on. It's going to set the duration to the ET duration that you have, and then it's going to set the pause to the ET pause that you have. As simple as that. Now that you're done with save frame, the next part would be playing the action. Now let's look where the play action is. So here it is, be play click. So suppose I want to play something. First of all, it's going to set the text of the button as playing, and then if playing is equal to false, so it's going to first check, if you're not currently playing something. The reason for this is because we're going to do this in the background, so there might be already a play action task going on in the background. If it's false, we're going to set it as true, and then we're going to enter this new async task called play action task. So I'm going to go and look at the definition of play action task. Now, this is going to happen in the background. It's really important that you understand that. The reason for this happening in the background is while you're playing, you don't want your GUI to get blocked. The reason for that is you might want to do like changes in the button. Like I said, we already set be playing. We set the be play text as playing, so that requires that all of this happens in the background, because the moment you enter this in the GUI thread, it's going to block everything. It's not even going to show you what you just wrote on the button. So now that we are inside the play action task, let's see how it goes. So first of all, it's going to write a neutral frame to your robot. It's going to wait for 1 second. This is just a failsafe that it first goes back to the neutral position and then starts from there. This is also the reason that we are putting the 0th frame as the neutral frame. And then what it's going to do is, if the action size is greater than 1, obviously, what we're going to do is we're going to go through each particular frame. We're going to check the duration, we're going to check the pause, and accordingly we're going to find the difference in the motor angles, and according to the difference in some motor types, we're going to do right degree sync function, which we have already used before. We're going to use this for all the IDs of the spider, all the motor types of the spider. I'm going to set all the positions with new RPMs. These are very important. The new RPMs are calculated here depending on the duration you want to go at. So once the RPMs are set, the robot takes exactly that much time to reach that position. While it is going, since the statement will get executed immediately, the motor is still reaching its position. We have to wait for the motor to reach that position before we give a new frame to the motor. So we're going to wait for exactly duration plus pause, and since these are in minutes here, because we kind of divided by 60 for RPM calculations, we're going to multiply by 60 and then 1000 for making it in milliseconds. We're going to wait exactly for duration plus pause seconds, basically. So even our play action is understood now. Now let's look at the enable disable button. We should have done this before recording, because actually we need to enable and disable the robot all the time before recording. So suppose we are looking at the enabling button. So first we obviously made it a toggle button by using a boolean variable, and then what we're going to do is we're just going to use this function called write enable sync AXMX, which is going to set AX or MX series to depending on what array you give. So if you give all ones, it's going to set all ones. That means it's going to enable all the motors. If it's all disabled, then it's going to switch off all the motors. Now by switching off, it doesn't mean that the motors lose power completely, but they kind of remove the torque from the shaft. So the motors are still on, you can still read them. It's just that the torque is 0 on the shaft, so you can rotate it with your hand without breaking the motor. Now that we're done with all of these things, now we need to learn how to save. So every time we click on save, first of all it's going to check whether my action name is mentioned properly, it's not blank and all of that. And then you can put some more fail checks. So depending on the size of the action, that means each frame we're going to set the duration pause, and each motor's position in a text file. So we're going to generate a text. We're going to put some characters to tell the difference between each variable that we're putting, and then we're going to put an e indicating the end of that frame. So I'm going to just tell you. So D is used for duration, P is used for pause, and then A means angle. So each angle is separated with an A, and then E means end of frame. So each frame is separated by an E. This becomes very handy when we try to read these things and then decode it into an action. We're going to get there soon. So after we convert the action into a text string, we're going to do a write to file. So when we do a write to file, the data is the data that we created a string from, and then we just need to send the context. Let's go into the write to file function. The write to file function is basically going to take the action name that is currently set on this particular activity, and it's going to create a text file, and it's going to save it in the private mode. So this means that it's not going to be visible on your phone memory easily. It's hidden, but it is there in the app data, so nobody can tamper with it. It's all safe as long as it is being used from the app. Now that we have written to the file, we may need to load the file as well. So we're going to look at what happens when we click load files. So when we load files, again, it's going to set a new alert dialog where it's going to show all the possible files that are there in your directory. So we have get list files, get files directory. It's going to give you all the list of files that are there currently on your system. So from the spinner, it populates the spinner according to this file list, and then it's going to, once it populates the spinner and you choose the file and you press OK, it's going to set the action name as that particular file. It's going to do all of that, action clear, and it's going to then read from the file. So we got the action name from the spinner, and then we're going to read from the file. So in the read from the file function, I'm going to enter the read from the file function. Basically, it's going to use an input stream and read from the file name we just gave it to. So it's going to read the text file, but then after reading it, what we're going to do is we're going to try to get action from string. Now this is again important. So we have get action from string. So remember how we had split each frame with an E. So this is going to split each frame with an E, and then it's going to put each of those strings in something called as lines, like in string array, and then it's going to iterate over each line, and then in each line it's going to look for the duration, the pause, and each angle, and it's going to make an action out of your thing by using frames. So it's trying to make an action, and then it's going to return an action to you. Now this action can again be used by you. Since now it's back here, we have saved the current action. So minded that the action variable here is a global variable that we mentioned on this particular app. So this action contains the latest action that you have. So when you load it and then you play it, as long as you're connected, it's going to just play that action that you just loaded. So I think this pretty much covers everything. I know this was a huge lecture because it covered a lot of things. Go through everything. I really hope that I did not leave anything. I think I've covered everything. I'm just going to cross check. I think it's pretty much covered. From the manifest point of view, I don't think there have been any changes from the previous time. These are exactly the same things that were there before. So I'm going to upload all the files and you can go through the files. Before we end the lecture, I would like to mention some things that we can go through when it comes to actually creating an app out of it. You need to do some checks before user presses anything. So keep a sort of count or some sort of state of the current app so that the user cannot press some illegal buttons when they're not ready. For example, if I'm not really connected to the robot, how can I play action? How can I record new frame? How can I create action? So these all buttons should kind of be invisible, or they can be blocked to the user, or they might give a toast to the user depending on the connectivity of the bot. Another thing might be, for example, when I play action, by default the motors go online and they have the talk enabled. So if I've disabled my button here and then I play action, automatically the button should get enabled again. So these are some things that you might have to add as features to your app. The load and save functions seem pretty safe. I think there's no change there that you need to do. Again, neutralizing will change the state of the motors. If they're disabled, you need to enable the motors again. We will cover some advanced features of GUI again in the following lectures, in which we might have to put some more things, some more features together along with these. And for now, this is it. I hope you are able to execute these things. And see you in the next lecture.